Why are NaN and none used for missing values in Python Pandas? Imagine you're working with data and some pieces are missing. How does your program know which data points are absent? That's where NaN and none come into play in Python Pandas. Let's explore why these two are used to mark missing values and how they work differently. First, think of none as a placeholder for missing data in general Python programming. It's a special object that means nothing here. You might use none if a variable has no value or if a function doesn't return anything. Now, NaN stands for not a number. It's a floating point value created by the IEEE standard, used to indicate undefined or unrepresentable numerical results like dividing 0 by 0. NaN is part of the NumPy library, which Pandas relies on heavily for numerical data. Since Pandas is built on top of NumPy, it uses NaN mainly for numeric columns. When you have a column of numbers and some data points are missing, NaN fits perfectly because it is a floating point value that Pandas can handle efficiently. This allows the column to stay as a numeric type, which is faster and uses less memory. But here's a key point. NaN is not equal to anything, not even itself. So if you compare NaN with another NaN using the equals sign, it will return false. To find NaN values, Pandas provides functions like isna or isnull, which are designed to detect these special values properly. On the other hand, none is used in non-numeric or object-type columns. For example, if you have a column of strings or mixed data types, none is a good choice to show missing data. Since none is a Python object, when you put it into a Pandas series or data frame, the entire column's data type becomes object. This makes it flexible but less efficient than using NaN for numeric data. The main differences are in how they behave and what data types they support. NaN is mainly for float columns, while none works well in object columns. Using NaN keeps your data in a numeric format, which is faster and more memory-friendly. Using none makes the column an object type, which can slow things down but allows for more flexibility with data types. When it comes to comparisons, NaN is tricky because it does not equal itself, so you always need to use functions like isna to find it. None can be checked with simple comparisons like isNone. Recently, Pandas introduced a new missing value indicator called pd.NA. This is designed to work across all data types, whether numeric, string, or Boolean. It aims to unify how missing data is handled in Pandas, but it is still being developed and used with special data types. For example, if you create a data frame with missing numeric data, you might write import pandas as pd and import numpy as np. Then create a data frame like this, df equals pd, data frame with columns A and B. Column A has some numbers and a NaN, while column B has some none values. This shows how NaN is used for missing numbers, and none for missing strings or objects. In summary, NaN and none are both used to mark missing data because they fit different needs. NaN is great for numeric data because it works well with NumPy and keeps your data fast and efficient. None is better suited for non-numeric data, especially when working with strings or mixed types. Pandas provides tools to handle both, making data cleaning and analysis smoother.